Hey guys, welcome back. This video continues off pretty much exactly where we left off last time, so be sure to check the previous video out if you haven't already, to get an idea of what we're working with here. But as a quick reminder, we're building this monorail system, and the agenda for today is to write a component that would make this monorail car over here, this guy, actually move along this track to the other side in such a way that we can actually ride in it along with a bunch of dynamic objects and things. And last time we set up an animation path for the track. So we have this line here with these waypoints along the way, and we have a path animation which we can preview, and you can see this what do we even call this, like a transform axis cross moving along the line, starting slowly, picking up speed, and then slowing down again when it reaches the other side. And so today we will take this monorail car and actually have it follow that. And I think the data should be pretty much set up now so that we can actually do that. So let's jump straight into Visual Studio Code and our component section here of the game project. And let's create a new component called, what do we call it? Monorail car component, something like that. Oh, I might have had some previous tests actually, that's why it says it's modified. Yeah, I probably had some previous tests actually that used that name. But nevertheless, we're gonna actually add it here, mono, we can just call it anything and we can import it with the proper name. So import monorail car component .zig, and in it we will have a monorail car component, which we currently don't have. Like so. So we go here and we do add a new component, call it monorail car component, and the registration name I typically add means dot to the beginning of the name to specify that this is a zig component in the means package or module. All right, so what do we need? Well, I mentioned previously that we're going to be using something called transform animation. So it is really essentially what we see here with this transform cross moving here. But this is called a path animation. So what's the deal? Well, the big idea is essentially that you can create transform animations in various different ways. One such way is by using a path. The output of this is a transform animation. And the transform animation is pushed to a data block in this level by this path animation component here. So when we know the name of this guy, this monorail refinery to lift station track path animation 1, if we know that name or that path, we can deserialize this animation as runtime and use it, just like any other thing that we load from a data block. So knowing that, how do we use this in Zig? I have this animation section here. We have transform animation, which, as you can see, is actually really simple. You have just a frame with a position and an orientation. And we have an array list of those. We also have a length and a frame rate. And then we just have a serializing function here. And that's essentially all that it is. It's basically just a list of positions and orientations. Then we have transform animation player, which we can initialize with a transform animation. And this guy then has a bunch of typical methods you might find in a player, like play, pause, stop, set playback position, jump to first frame, jump to last frame. This update is perhaps the interesting part here. When you update it, if it actually has played the animation, it returns true, otherwise false. And as the animation is playing, we can simply read the current position and orientation out of the animation, and that should give us everything we want. So, with all of this information, let's start actually putting this thing together. So we know that we will want an animation, and it is of type basis animation, transform animation. We also will want one of these players. So basis animation, not AngelScript, animation, transform animation player. And somehow we need to be able to point this monorail car component at this animation that we have. Like we need to essentially be able to give it this name. Where should it find the animation data? And I'm thinking maybe we will actually just have that as an expose property. So let's do animation data block name, which can be a string. And yeah, I think that's probably it. So let's just add a comment here that we have the exposed properties after this comment. And exposed property, I mentioned this before, but just as a reminder, an exposed property is something that appears here in the game object inspector. So kind of like how public variables in Unity appear as adjustable and serialized data here. That's basically the idea behind exposed properties in Basis, but you need to do a little bit more work to actually get them to show up, because C++ and Zig doesn't have quite the same reflection and introspection thingy as C# and Unity. Maybe Zig actually could have that, but yeah, this is driven by C++ under the hood. So to get these to show up, we need to put in something called an exposed property map, and everything that we put in here will show up in the inspector. So exposed properties, and what we have here is a string property. So parent type is just self. Field name is animation data block name. Default value can just be empty. Version added is always just 1, and options, you can add options if you want to. We don't really need anything here, so that's fine. And then we need to figure out how should we actually start this animation. And we could of course just have like a public method here, like public function start or something like this, and this would start the monorail, and maybe that is how it will work in the end. I'm not exactly sure, but since we've been working on our scripting layer lately, and it is so easy to actually use it, I figured we're just gonna script this. It might be the best way to actually trigger this kind of stuff in the final game too. So that can be a pretty good idea. So to be able to script this, what we need to do is we need to add a script code container here. So basis angel script script code, and it also needs to go in the exposed property map. So basis exposed properties script code property self script code. The template is one of the available templates. Typically, I use script. Version is 1 and no options. So the options allow you to like nest these if you want to have one nested underneath another one in the inspector window, or you want to give them a different display name or something like that. All right, and so now it has somewhere to store the script, but we still need to actually register this type to make it scriptable. So register angel script, I think it was. Registration, and it takes an angel script component registration and returns void like this. And the only thing we can do so far is to register the actual type itself. And so we're just going to use monorail component as the name. Oh, component. Like so. For the type. Typically this doesn't really matter. You could typically input essentially anything here as long as it's unique. You don't most of the time you don't really use this, but it still has to be like AngelScript is a strongly typed language, so you need to have a type for it set up properly. And now if we build this, it probably won't build because we haven't actually. Oh, well, we have the same thing here apparently. Component, like so. We haven't initialized everything properly. Well, first of all, we need to just type this correctly. But now that we have, yes, we're missing initializers here for things. So let's initialize everything. So animation needs to be initialized with basis animation, transform animation, and init. And the reason we need to init it is because it needs an allocator. Like so. The animation player actually doesn't need one, if I remember correctly. Animation player init, and it actually wants an animation, but I'm hesitant to actually pass the pointer there to it, so let's just give it null currently. We can see here from the type that this accepts, it's an optional type, so we can just give it null for now. We don't have the animation yet. We will pass it the animation when we've actually loaded it. The animation data block name also needs an allocator, so that would be a string init and context allocator, like so. And finally, the script code also needs it, and init and context allocator. Yeah. And then before we forget, we better make sure to actually release these things. Data block name needs to be, the player doesn't need to be, it doesn't really allocate anything, so there's really nothing to de-initialize there, or release essentially. So this should be fine. Now I think this should build. Not quite. Animation player will. Oh. Having a hard time typing things today. Still have a little bit of a cold going on, which you can probably hear from my voice. It's a little raspier than typical. Okay, so now we can build this thing, and the next thing I think would be to actually let me look at my notes here so that I don't forget something. Yeah, so we're gonna want to load the thing, load the animation, right? And maybe we'll use onObjectCreated for that. So if we're not in the editor, and also if animation data block name is not empty, then we will want to load the data. And so first of all, we need to access the level data because it is exported as part of the level data. So game session get level data, and from level data we can actually get the level data block manager, because it is specifically a part of the level data blocks. As a very, very quick primer, anything that any like object and all of its exposed properties and things like that that you put in the level is obviously exported as part of that level. But then certain things such as this path animation component can export extra things, like any essentially binary data that it wants to bundle with the level data. It can create a so-called level data block and just write it there. And so that is why we're going through the data block manager now to get the thing out of there. And the data block manager has something that could almost be considered sort of a small file system. So it has something called these if statements are kind of messing up the language server again, but it has something called has data block. So we can check here if what we have in this member is actually a valid data block. So this is almost like a mini file system, if you will. So it's going to write something there if we actually have it. If we don't have it, then we should probably give some sort of warning. Debug warning, could not load monorail animation from, and then what was it, like this, something like that. And then the arguments, that would be self animation data block name str. Right, so we get a red text in the lower right corner if we have somehow managed to misspell the data block name, or we remove the animation, but the actual monorail is still there. Then it will tell us that I can't. Okay, so now let's get the data block out of this thing. So data block manager, get data block. Mutable data block, no, we just need a read-only data block. That would be self animation data block name str. Yeah, so mutable data block will actually give you an error if you try to do that outside of the editor. Right, so we have get chunk. So data block is named, but it can have one or more chunks. You can called get chunk count to figure out how many there are. And then you have also try get chunk, and I think we will need to use try get chunk because if you look at the actual animation, it has this try deserialize. So this uses the standard error handling mechanism of SIG. So if you have like a very simple type like a float or something, you can just call get chunk. If you have something that actually does error handling, then you need to use try get chunk. And what we will get out of there is a basis animation, transform animation, and we give it the pointer to the animation like this. And right now we should have the animation loaded, so now we can actually pass it to the animation player. So now we do the same thing that we did previously. We initialize the player, but we give it the address of self animation like this. And I think what we should do here now is jump to the first frame directly. And after that we should probably apply the transform to this, because like if we change this path a little bit, but we don't actually position this car like directly where the first waypoint is, then it will sort of jump there. It will sort of, if we consider it to be there when we play the animation, first it will like jump to the first one, and then it will start playing. So it's probably best to make that jump ourselves, right? And the way we can do that is through the transform API. So we do self context transform set transform. So right, we have position, position, orientation, and whether or not to teleport. And yes, this is a teleport because we sort of snap it there into place. So self animation player current position, animation player current orientation, and true. Maybe we can do it like this. So teleport is true, and yes, we want that. It's a bit clearer later on what this means. Well, sometimes you get these hints, but they don't always show up, I find. Okay, so that's cool. Now we have the animation loaded. We should probably actually be able to play this now. The thing that is missing is actually setting the transform to like essentially doing this part over and over as the animation progresses. And if we look at the animation player, I mentioned briefly this update method here, or function, member function, which returns true if it has actually modified and false otherwise. And we can use that to our advantage. And I think the correct place to actually apply or set the new transform for this guy is in the pre-tick. So I have a snippet here for adding a pre-tick method. I don't think we need these things at all. But basically I think I've mentioned this in previous episodes. Update is fired every update of the application, so it is a variable time step. Pre-tick is fired before every physics simulation, and tick is fired after every physics simulation. So I think pre-tick is the thing that we will want to actually update it in, and then let the physics simulation handle the movement. So in here we should be able to just do if self animation player update, and we'll just pass it the tick delta time. So if update returns true, then that means that that something happened. We need to react to the change in the animation. We'll basically do this, but this time we don't want to teleport actually, because teleporting is used to sort of snap the object to a new place. So for example, if you move it like all the way across a level or something like this. We don't want to teleport now. We want to move it into the next position. And if we if we teleport, then the engine disables all the interpolation and everything for that object during the teleport. So that will look choppy, or it can look choppy. This should look better. Right. Okay. So what do we need next? Now we are loading the animation, and we are essentially applying the change to the object. So we have two problems here. Still, first we need some way to actually start the animation, and that can be solved by exposing like a play or start method to AngelScript. The other problem, and the one that is a little more involved, is the fact that this guy sits on both sides of the network. And typically these kinds of scripted objects, they're driven by the server. So the script will most likely fire on the server, and that will make it move along this track on the server. But since this is a kinematic object and it's not driven by the physics engine, it's not simulated by the physics engine in the same way as a true dynamic object, it means that the client-side visualization, the client-side representation of this object won't move nicely and smoothly along with it. It will essentially sort of snap from position to position, or at least that is how it has been, how it has behaved in the past. So we're gonna actually have to probably play this animation on both sides, and it's not really a problem, it's just like a little bit more work. But let's try to get it playing on the server first. That should be reasonably straightforward. So, as we have done previously, probably actually don't need this onMessageReceived method, so let's get rid of that. And we will add a start animation method here, like this. So self animation player play. All right. And if we want to script that, then we need to add the so-called wrapper function to allow AngelScript, which doesn't really know Zig at all, to actually call into this thing. And this needs to be call convention C, and then we get the actual proper self basis AngelScript get component self out of this int pointer. So now we have the actual Zig self, and now we can call start. Oh, it's not FB, it's FN. Now we can call the proper start animation function, so this guy. And now the only thing that remains to be done is to register this method. The declaration would be void start animation. We don't need the underscore there. Function pointer would be just that, I think. Yeah, so that should work, I think. Let's build that and try it out. Now the problem is, of course, that start animation now always starts at one end of it always starts here and moves in that direction. With this, you can't go back from there to there. But we'll get to that. We'll get to that later. Maybe we don't even need to do that for this video. Okay, so I'm gonna we still have this preview running here. I'm gonna unload this because we get access denied, and that makes perfect sense because we have the engine running there in the editor. So we probably still have, we have this guy running. So disconnect from game. There we go, and now we can see. Okay, and it succeeded immediately. Cool. So, with a little bit of luck, this should now give us our first very choppy animation. But of course, we need to still add it here to the actual type. We don't use this component anywhere yet. Let's copy this to make sure we get it right. Component type is that. It will, as usual, it will complain that we haven't added it here to the asset browser as a registered type, but that's fine. And now we need to make sure that it is on the client and the server. So cool. Actually, we don't really do anything on the client currently, but we will want it there once we get this networking business sorted out. So one thing that we can maybe do is run it directly from here. We need to somehow script this guy now. So first of all, now that we selected, we get a nice script here. So that's pretty cool. We get the animation data block name. You can see that it figures out how to write this prettified name here directly from our animation data block member variable here. So that's kind of nice. And the animation is, of course, this guy here. So we can plonk that in there, and that should be fine. I can make sure that it actually exports. And it does. But actually what we will want to do is start monorail, something like this, and start animation. So I mentioned in previous videos that if you add this dev here, this appears as a function that you can just run from the top menu in the game, like from here basically. And you can even do something like go ride the monorail like this, and now that text is what actually appears there. We will spawn over here though, so maybe we can do something about that. What should we do about that? Let's add this guy up here and put him inside of the car, somewhere along there. And we can take actually we can do this. Let's do monorail avatar, something like that, and that would just set the avatar to that guy. So level objects, what is it? It's monorail, refinery to lift station, track, or is it actually? Oh, it sits right. Yeah, okay, it sits under that. So it would be test vehicle 1, like so. Okay, let's see if this works. So now we will want to run these scripts on the server side. You can see that we have both of them here. We have them on the client side, we have them on the server side. We definitely want to run them on the server side. So monorail avatar first of all. Yes, we are now here inside our car. That's cool. And I wonder what happens now if we actually ride this thing. So you can see, yeah, starts moving. Actually, yeah, it seems to work quite nicely. It works. Oh, now you can see. Yeah, right. I was waiting for something like that. Yeah, let's pause this thing. Can we actually see the server side physics? No, we can't actually see the server side physics here. So what I'm gonna do now is I'm gonna export this. We can minimize that guy. Actually, we can unload the engine and then we can minimize it. And let's go here to launch and make sure that we can. If we set server thread to false, then we can visualize the server. Oh, not the GPU profiler, but the render options. And monorail avatar, right. So, okay, we can see yellow lines and we can see green lines. So the yellow lines are the server and the green lines are the client. And now if we run this thing, my guess is that the yellow lines will continue to move smoothly. Yeah, you can see. Yep. Yellow lines continue to move smoothly. And the green lines and indeed the visual representation just starts chopping. And so basically what happens is that when it snaps because the client and the server representation of the transform is sort of too far, and then it corrects itself a little bit, and then it snaps again because it determines that it can't catch up. And of course it doesn't even really try to catch up because the client doesn't play the animation at all. Okay, so how should we actually do this then? Well, there is, just like we have propagated values that we can set on one side of the network and they appear on the other. We also have propagated actions, and I think a propagated action is probably the correct thing to have here. Now we are in the wrong component. There we go. This is what I want. So let's add here a play animation action, and it is of type basis network propagated action handle. Yes, because you use the handles to actually represent those things. And this will be initialized with a propagated action in it. You can see here that it returns a propagated action handle. So context is context. Name is just like play animation or something like that. Reliable is true, and immediate can also be true. I mean, this action won't fire that often. So it makes sense that we actually we make sure that it fires as soon as it can. And then we need to deinitialize it. Like so. And now instead of playing this animation here, we can simply fire this action. And since we are running this code on the server, it will also fire on the client. But what does that mean? Well, a propagated action is not really all that useful without some kind of handler for it. So we need to basically add a new section here and have on I'll call it start animation and play animation. Maybe we should just call it start animation everywhere. Start and start and start and start as well. So on start animation fired. All right. And just like the propagated values, we need to specify here or give some parameters here if it's a local change and what the value time is. Value time is sort of a silly name for an action because it doesn't really have a value time. Or we could call this action time like this, and it would maybe make more sense. But typically it's called value time, so I'll just call it that for now. And in here we can then do play animation. No, actually, sorry, not that. Not animation player play. Like so. All right, and we need a self, obviously. That's why it didn't work. That's why we didn't get any auto completion. And actually, what we change is what it should be called. Like so. Maybe before we do that, we actually should check if if the animation is or isn't null, right? I think maybe the play function already checks it. Yeah, it checks if it has an animation or not. So yeah, we don't really need to do that. We don't really need to do that. Okay. That's cool. And now we still need to hook this up to the actual action so that it fires. And we can do it here in create, for example. That's typically where I hook up these kinds of things. So set action fired callback. And it is of type basis, network propagated action, callback. And we want to initialize it not as a function, but as a method. So receiver is self with a big S. The receiver type is self with a big S, and the receiver is self with a small s. And then we have this. And I think that should be it. Play animation action. Yeah, we renamed it to start animation action. That's true. And what now? Oh, it's the other way around. That's supposed to be with the small s, and that's supposed to be with a big S. And if that looks silly, then of course it is just because we have our self, or this pointer is just called self with a small s, and self with a big S is really just an alias for this type. So we could, wherever we write self with a big S, we could just write monorail car component. But I typically alias it like this. Cool. And maybe we can add a comma here to have it format it for us a bit nicer. Okay, so now I think we should have everything we need. So start animation, which is triggered from the script, now fires the thing. The thing is hooked up to this guy, which fires on both sides, and it calls self animation player play. So it plays on both client and server. And we can try this out. And we enable the physics visualization for both sides again. And then we run this on the server. And here we go. You can see a little bit of glitching there with those visualizations. It's because they're not actually interpolated like the visuals are. Yeah, that looks better. That looks better. That definitely looks better. So now if we actually we can even sort of drive around here, but it's a little tricky since this is moving. But we're not falling off, at least. Although since we don't have actually like a side to that thing yet, the gray ramp on the side, we can actually fall out through that side quite easily. And then we come to a stop. Hey, isn't that nice? And we can just drive out of it like this. Okay. Well, that's fun. Yeah, there's no collisions for this track yet at this point. I probably have to put that in. Even though it's kind of high up in the air most of the time, but still, it probably makes sense to have collisions for that. Okay, so that's nice. Let's play around with this a little bit because it works quite well. Now we can start to sort of test the limits of this system. So we can add some dynamic objects here. Maybe we should create new layer for these guys. Auto load. I'm not even gonna name it properly. Let's call it layer 8. Something like this, and then we can just duplicate it once more, like so, and then we see how well does it actually handle this kind of thing. We have a bunch of boxes there, and we start the thing. They just move along very nicely. So one interesting thing that I realize here is that I can't actually reverse. Things are moving, sliding around ever so slightly. And that's fine. Yeah, I can't actually like reverse here now. And I think the reason is that I have my automatic gearbox for this car is kind of considering us to be traveling forward still. And so if I hit reverse, it basically just brakes. And I bet that now I'm holding like the brake, which should switch into reverse. And now that we're moving slowly, yeah, now it sort of released it. Okay, that worked. I mean, the movement is so smooth now since we have this S curve which kind of controls the speed of this thing. So basically, this guy. Oh, that's not how you do it. That's how you do it, like this kind of thing. It starts very smoothly and then ends very smoothly. Let's try linear normalized. Now it should like immediately kick into speed, and this will probably make everything just fly off, or at least let's go see. So boom, yeah. Actually took some time before they fell off. But yeah, I mean this works really quite well. Yeah. And then it won't slow down at all. It will just keep going this speed until it then essentially stops. So that's interesting. And yeah, I have another thing that I want to try actually with this. Come to think of it. So, boom. Yeah. Yeah, this works well. Right, so what I want to try is let's get a bunch of these things. Where's like a somewhat flat plane? Well, we can make a flat plane for us. So let's do like primitive geometry. Make this large enough, so like 30, 130 or something like that. And then put some of these boxes on it. So like box. Actually, let's make it even tighter. What I want to see is how dynamic objects react when this thing actually like runs into them, so to speak. Let's actually lock this so I don't accidentally select it. We can simulate those guys. Let them fall down. That's fine. Then we bring these over a little bit. We simulate them. That's fine. And again, we add some new ones. Oh, come on. Come on. And there we go. So we have a little wall there. Maybe the wall should be somewhere there, and then we'll put like a truck or something there. Let's see how that behaves. So something like this. I think we need to make this guy have default ground so that the truck's wheels will behave. And then what we can do is we can take some of these points here, and we can quite simply move them off to the side for a bit and use them to actually have this thing drive into these obstacles that we've set out here. Yeah, now it intersects with the plane a little bit. That's probably not what we want. What we can do is bring this down. Yeah, that looks better. That looks better, but maybe it's still a bit close to through the ground, so something like that. So now should this should be interesting, because yeah, this will just throw probably everything off the thing, but it doesn't matter. Like I'm not even gonna save this level. Let's just try this and see what happens. I can be the avatar. Yeah, sure. I can be the avatar, and there we go. And now it will, at some point, it will just go completely crazy and just fly off the rail and do its own thing. And as it does it, makes a pretty sharp turn, like so. Things just fly off. Oh no, we fell off. Okay, so what happens now then? Yeah, it just kind of pushes things out of the way, but that's fine. Obviously, this monorail won't do crazy moves like this in the game, but it's nice to just see how these things work, because I might be animating other kinds of things like this in the future. But but yeah, it worked kind of how I supposed and also hoped it would. So cool. And now that it's there, we can of course again we can make it restart its animation, and it will do the same thing again. Okay, fun. I think we're done for today. This worked pretty well, actually. I was kind of preparing myself to have to deal with some weirdnesses, but no, this works quite well. So I'm gonna have to figure out how I actually want to control this thing later on. Maybe we should actually be able to just drive the monorail yourself with like one of the sticks on the gamepad. You can move it backwards and forwards and things like that. That could be kind of interesting, because then you could use like the crane on the mother vehicle to lift things onto it, and all kinds of fun things. So that should open up a whole new set of possibilities for gameplay. But now we can just undo all of this. Undo. Even more. Undo all the things. And now we can just delete the layer like so, and we want to set back the smooth normalized curve. And now we should have the nice smooth ride again. Except where's... Oh, yeah. The other boxes were part of that layer that I removed. But that's fine. Okay. so that was fun. This basically works exactly how I hoped it would. Now I know roughly how this will work, and I can get back to modeling, fleshing out this area, this monorail station. If you have any comments or questions or anything regarding this, let me know in the comments below. If you have any suggestions on what you would like me to cover in this series, let me know as well. I'm doing all kinds of things, like almost like simultaneously now. As you can see, I'm doing like level design, and I'm doing programming, and I'm doing even tech work where it is required. So let me know if you're particularly interested in any of these areas. Anyway, with that, I thank you for your time. I hope to see you in the next video. Have a good one.